go on to the first major content area. Includes all the test and measurement concepts. It isn't statistics. Statistics is in research and evaluation, although some folks kind of lump all of this together and it's aversive no matter what you call it or where it shows up. But let's talk about appraisal first of all, tests and measures, and then we'll ease into research later on this morning. The definitions in item number one, I'm going to just leave them. You can look at them if you want. I'm going to head on to item number two, measures of central tendency. Very often when we use tests and inventories, we will test 100 people, 200 people, whatever it is. We have 200 scores from a sample from a group who've taken some test or inventory. We look at the 200 scores, we say, well, that's nice. So what do we do with them? Well, we have to do some measures of central tendency and probably measures of variability minimally. So let's talk about measures of central tendency to begin with. And there are three of those measures of central tendency: the mean, the median, and the mode. The mean is your average. You add up all the numbers in your group and divide by the number of people in the group, and that's your mean. You don't need to know any formulas for this exam, none at all. You can't take your calculator in, so you're not never making any calculations on this exam. So everything's got to be in the head or figure outable between your head and what's on the paper or what's on the computer, okay? Mean, median, and mode. The median is the middle score in a distribution. The middle score, so half the people are higher than that score, half the people are lower than that score. That's the median. The mode is your most frequently occurring score. Your most frequently occurring score. And when you have a normal distribution such as this, bell-shaped curve distribution, they all three fall in the same spot. The mean, median, and mode all fall in the same spot, okay? Now, often, we're going to have a distribution that is not bell-shaped curve. You're going to have a skewed distribution. And I have two examples of skew in the next item. A skew to the right and a skew to the left. And let me give you an example, talk you through an example of a positive skew, something like this. And obviously the mean, the median, and the mode do not fall in the same place with the skewed distribution. I'm going to take household incomes in North Glen. I think we're pretty close to North Glen, maybe we're in it. Household incomes. On a skewed distribution like this, where is my modal income, household income? Where's the mode generally on a skewed distribution? The mode is always at the top of the curve. That's your high point of the curve, that's your mode. And so our mode would be right here, our modal income, and that's kind of the easiest one to figure out, and if you can figure out the top of the curve. Now let's say that the mode is the most frequently occurring score. Let's say that the most frequently occurring household income in North Glen is 42,700. I have no idea. Well, I have some idea, but let's go with 47,200. There are more 47,200 household incomes in North Glen than any other income. That's the mode, okay? The median would be which way? It has to be this way, okay? Let's say the median is over here. And let's say that the median household income in North Glen is 51,700. Okay? 51,700, the median income. Half the incomes are below that, half the incomes are above that, household incomes in North Glen. Okay? That's what median gives you. So your mean would be which way? That way, okay? Further off to the right, let's put it over here. The mean, let's say that the mean household income in North Glen is 62,800. Why is it so high? Guess what? I've got a skew to the right. There are some $1 million household incomes in Northglenn, or $500,000 or $250,000 incomes in Northglenn. Those extreme scores always pull the mean in its direction, okay? So, if the extreme scores are here, that's where the tail's gonna be, that's where the skew's gonna be, okay? It always happens. If you have a skewed distribution, there are some extreme scores pulling that whole thing that way. And that's the mean. So, we have 47.2, 51.7, 62.8. If you were writing an article for a Northland paper about taxes and the need to lower or raise them, which one would you use? Which one would you like to use to sway the readership? Would there be one that would be better than that? Better than another? Well, most frequent, if you wanted to say that, we've got some poor people here, you'd use the modal one. If you'd say that, we're pretty well off, you might use the mean, but only a few people meet that mean or are higher. So the median, probably half above and half below that, would be your best, most accurate measure of household income. That'd be the 51.7, okay? Now we could flip that over, turn it over, and do the negative skew the same way, and you see those in item number 3. Now we need to go to the measures of variability. We talked about measures of central tendency. Let's get measures of variability. The most simple measure of variability is called range, where you simply subtract the low score from the high score, and you add 1 if you want to. Let's take women's shoe sizes in this room. We have women here, maybe let's say the sizes range from 5 shoe size to 10 shoe size. So what's our range? 5, subtract 5 from 10, you get 5. But so we have a 5 in here, a 6, a 7, an 8, a 9, 10. We need to add 1 to be inclusive. So my range that I like to see used is subtract low from high and add 1. Then everybody's included. It's an inclusive range. We have a 5 in here, a 6, a 7, an 8, a 9, and a 10, okay? A good measure of range. Range is good when your number of individuals is small. And if you've got big numbers of people taking a test, an exam, inventory, range probably won't work well. And so your better measure of that would be standard deviation. Standard deviation is a long, complex formula, but it's pretty easily understood. Let's say all of you took, I'm going to give you 2 tests, by the way, this morning. A test of hostility, and one of anxiety. And then we'll look at the correlation between that, anxiety and hostility. Let's say on the anxiety test, there's about 20 of you here. We could subtract the low score from the high score and add 1 to get our range. For standard deviation, I would figure out what the mean score is of you 20 folks on that anxiety test, what the mean score is, but hardly anybody would be right on that mean. You'd all be devious. You'd all be deviations from the mean, right? You'd be just a little bit off. Some of you would be a ways off from the mean. Well, standard deviation is the sum of all those deviations. That's what standard deviation is. It's a really good measure of variability, and you can use it with tons of folks in your sample. In fact, the book says you ought to use about 120 people to do this well, standard deviation, but it's used for samples of 15 and 20 and 30 and so on. But standard deviation is the sum of all of those deviations from the mean, so it becomes a very, very good measure of variability. Now the next one down is called variance. Variance is simply the standard deviation squared. It's not nearly as representative of the distribution of scores, so it's not quite as good in terms of representing variability, but it's still a good measure. But standard deviation is our preferred measure of variability, and then range for small numbers of individuals, okay? Measures of variability. Now, let's go back to the normal curve, and you can look at the normal on the next page, and I want to identify some of the characteristics of that normal curve. Get rid of this. Some experts in measurement have divided the normal curve into 8 parts. Now we're going to talk about 6 parts. 6 parts encompasses almost everybody that's tested in our experience. So we're going to go first apart here. This is 1 standard deviation above the mean, minus 1 standard deviation below the mean, okay? 34% of the individuals in my sample are in this part, 34% are in this part. So from the mean to 1 standard deviation, 34% of the people in my sample are represented. From the mean to minus 1 standard deviation, 34% of the people are represented there. If I had let's say I had 1,000 people in my sample, 68% then are accounted for with 1 standard deviation. That's 680 folks altogether are accounted for in 1 standard deviation. What does a standard deviation mean? Somebody who has a 1 standard deviation, let's say that you're a school counselor and you have some test data on a student, or you're working in an agency, a clinic, and one of your clients has taken some instruments, some psychological test or inventory, and you get the scores back, and that person is at 1 standard deviation above the mean on some psychological trait or characteristic. What does that mean? That means that that person is right here. That person is higher than 50%. See, 50% up to the mean. This is a, normal curve. 50% up to here, up to the mean, plus another 34. That person is at 84% of possible scores at 1 standard deviation. 1 standard deviation doesn't seem high enough to do that, but it does. It takes 50% plus 34% to be that individual. Now, somebody profile came back and was minus 1 standard deviation. That person never made it to 50%, and you subtract 34%. That person is at 16% of possible scores with a minus 1 standard deviation on some psychological trait or inventory. 16%. That's pretty low. So 1 standard deviation goes quite a ways. Now let's go out another set. We said we have 6 parts we're going to talk about. 2 standard deviations there, minus 2 standard deviations there. 13.5% of the individuals are in this part. 13.5% of the individuals are in this part. I've now accounted for 95% of the individuals in my sample. If I've gone out 2 standard deviations, positive and negative. 95. So out of my 1,000 sample, 950 folks are represented. Do you know how high 2 standard deviations is? So when you get back your test results from NBCC, and you can figure out your standard deviation. If you're 2 standard deviations above the mean on your test score on the NCE, that means that you're higher than 50% of the people, higher than another 34, higher than another 13.5. You're at about 98% of possible scores at 2 standard deviations above the mean. Higher than 98%, 97 point something percent of scores. Incredibly high score, 2 standard deviations. Now, of course, if you go the other way, if you're minus 2, that means you didn't make it to 50, you lose 34%, you lose 13.5, you're at about 2.5 possible score there, percent in terms of that sample or that psychological trait or characteristic. Okay, so that's what the next two do. Let me see if I can use another one. Let's go out 3 standard deviations. So 3 standard deviations positive, minus 3 standard deviations negative. This is 2% of the individuals, another 2% over here. I've now accounted for 99% of my people in the sample. That's 990 overall folks. 3 standard deviations, pretty incredibly high. You can see that this is at about 99% of possible scores. 50%, 34, 13.5 plus 2 at about 99% of possible scores at 3 standard deviations above the mean. Now, if this is a client of yours, this could very well be the wild and woolly one that walks in the door and you say, oh, damn, here comes Joe again. What do I do with Joe? His or her, maybe she problems are way out there and hard to deal with. So on some psychological trait or characteristic, that person's at 99% of possible scores. And on this side, it's at 1% of possible scores. So hopefully you're not dealing with somebody on the intellectual scale and their standard deviations at a -2 or 3, but if it is, you've got a challenge. So that's what standard deviation looks like. Now, 990, we still have 10 folks hanging out, and so if my sample was large enough, like 200 in my sample, or 500, 1,000, I'd still have about 5 folks hanging out here and 5 folks hanging out here. On smaller samples of 50, 100, maybe 200, you wouldn't even have that many in the extremes. You might have 1 or 2 in the small sample hanging way out there. Okay. So the normal curve and the standard deviation, that's what that looks like. Once in a while, I'm going to move on. I'm going to come back to the normal curve, but I'm going to move on to item number 7 now and talk about standardized scores. Standardized scores are what I refer to as common languages. Standardized scores work like this. Let's say that you give 3 or 4 different tests to, maybe an elementary school student, and test in reading, math, and so on. Well, let me read you through the example in item 7. A person has a raw score of 60 on a vocabulary test and a raw score of 45 on an arithmetic test. Which performance is better? We can't tell. Correct comparisons are not possible. After we convert both scores to a standardized scale, we can realistically compare them. Okay? So, same person, so 2 or 3 tests. We want to compare the scores, but because they're different tests, you can't just say, well, this 94 is equivalent to this 47 or whatever it is. You put all the scores into a common language, a standardized scale. Okay, and once you do that, you take that raw score and you convert it to a standard scale score, you can compare them directly. Now, there are 2 standardized scales that I want to talk about. One is the z-score distribution on the bottom of the page. The z-score distribution has a mean of 0 and a standard deviation of 1. So I'm going to draw it out here, z, standard deviation of 0 and mean of 0, standard deviation of 1. So it looks like this. Guess what? It looks a lot like my original standard deviation, but it's interpreted actually the same way on the scale. Mean is always 0 on a z-score scale. Standard deviation is 1. So again, if somebody had a 2z, -2z, that person is right here, never made it to 50%, subtract 34, subtract 13.5, that person's at about 2 or 3% of possible scores with a -2z. Same thing works on the other side. Somebody has a 1 standard deviation, a 1 z-score, it works the same way, 50% plus 34, that person is at 84% of possible scores with a positive 1 z, z1, okay? So it made the use of tests and inventories easier to be able to put them on a standard scale and then compare them. One of the problems with the z-score distribution is that you have negative z's, and there are people who use these scores mathematically. They can add, subtract, multiply them, and I'm not sure I've ever met any person like that, but they say they're out there. Well, what they tried to do is eliminate all the negatives, so they decided to form another standardized scale called the t-scale. So the t-scale has a mean of 50 and a standard deviation of 10. So I go up to 60, 70, and 80, subtract, and I go 40 here, 30, 20. Voila, no negatives. I can't get a negative t-score, okay? But it works the same way. It's another common language, so I convert raw scores into this t-scale distribution and then compare people directly on multiple tests, okay? So again, somebody with a t of 30 never made it to 50%, subtract 34, subtract, that person again is at about 3% of possible scores with a 30t, okay? Interpret them the same way, okay? Common languages, the standardized scales. Okay, I'm going to take you through a couple examples here, one for the Z and one for the T. And let me do the Z first. Let's say that somebody takes the test has a mean score of 40, and the standard deviation for the scale is 5. The person takes the test and ends up with a z-score equal to a -1z. The question becomes, what is that person's score? Okay, we're on a z-scale. The test has a mean of 40, standard deviation of 5. The person took it, generated a z of -1. What is that person's score? Say it. 35. 35? I hear 35, kind of shyly out there somewhere. We're on the z-scale, okay? The 40 is equivalent to the 0, mean and mean. Each of these spaces is worth 5 points. That's my standard deviation, okay? So I start out here, the mean is 40, and the person has a -1z, well, that's right here. So I have to subtract the 5 from 40 and get a 35, okay? Piece of cake, okay, easy on that. Let's do a T example. On this one, a person, let's see, the test has a mean of 140. Standard deviation is equal to 12. And then we have a person's score equals 164. The question becomes, what's the T for that? Okay, so the test has a mean of 140, standard deviation of that is 12. The person took it, scored 164, equivalent to a T of 70. Okay, a little bit more assertive this time. 70. Remember, when you're doing that, now you're on a T scale down here. The mean 50 is equivalent to the 140. Each of these spaces is worth 12. Standard deviation is worth 12. So 140 and 12, 152, that would be one standard deviation. That's not good enough. 152 plus 12 is 164. That's a T of 70. Okay. Manageable? Okay. Good. Okay. Let's go back then to the normal curve, and I want to review some more of the features of that curve with you. We've talked about the z-score and a t-score. The next line down under that is the CEEB score, and that stands for College Examination, Entrance Examination Board. It's the SAT is what it is, the SAT exam test, and it's changed its names now 2 or 3 times since I've known it. It's called the SAT Reasoning Test, SAT. You see that the mean score on the SAT is 500. The standard deviation is 100. So very, very big numbers compared to what we've been talking about, but the concept's the same. You apply the same principles. So the GRE works the same way. Some of you had an affair with the GRE prior to getting into a graduate program, and you had a verbal GRE and analytical, verbal, and quantitative, right? Or something like that. Each one goes from 200 to 800. 500 is the mean. So you can see where you stood depending on your own scores. So the SAT and GRE work with the same way, 500 for the mean. The next line down is called the deviation IQ. When the IQ test was first designed by Binet and then revised by Stanford University and then also the Wechsler scales, in the US they pretty much settled on 100 as the mean IQ score of individuals in the US, and standard deviation is approximately 15. I think the Wechsler scales or some set of scales may push 16, but if you remembered 115 for IQ scoring, you'd be in good shape. 100 for the mean, and a standard deviation of 15. Stay9, the next line down, is also has a line on the next page in item number 6, Stay9. Stay9 is a word that comes from 2 words, standard 9, designed by the military way back when, 40s I think, when computers were first starting to be used in military applications. And it was a way of conserving space by dividing all distributions into 9 parts instead of 10 parts. And so on the IBM card, those of you who saw them in history books remember that there were IBM cards with 80 columns on them, and you'd only need to use 1 column with the Stay9 distribution rather than some other distribution. And so the Stay9s have been fairly common and popular, especially in elementary and high school circles, K-12 kind of settings. Children's scores being reported back to moms and dads as Stay9s, 5 Stay9 being in the middle, and then you see how they go to the left and right of that. So the little girl who comes home and says, Mommy, I just got a Stay9 of 2 on reading, can we go to McDonald's? And the wise mommy says, what? Nope, not today, not with a Stay9 of 2. I think we're going to go visit your teacher instead. We'll go see what teacher says. Of course, Johnny comes home with an 8 in math, a Stay9 of 8 in math, and says, can we get something for that, Mommy? And she says, yes, Toys R Us, let's go. Bring the cart. 9 Stay9's pretty nice. So that's how Stay9s work, not with the kids necessarily. Percentile, the line on the bottom, we've all used percentiles often, and so on. You see how they're distributed there, how they bunch in the middle, because that's the top of the curve where most of the people are in a normal distribution. Well, in any distribution, the top of the curve is where the bunch of people are. Let me give you a couple examples. Let's go up and down the chart, working through these. These are all equivalencies. Let's assume we have a person with an SAT score of 650. How many standard deviations above the mean is that? 1.5, exactly 1.5. So that's 650 would equate to, and for that person higher than what percent of scores is that 650? higher than what percent of scores is that 650 SAT? Take it down to the bottom line and kind of guess a little bit. Yeah, somewhere early 90s, 90, 92, somewhere in there. And finally, what is that person's T-score? 65, exactly 65. Another example, assume that a person has an IQ score equal to a T-score of 25. What is that person's IQ score? Once again. Yeah, 60, 62, again, we're guessing a little bit, but somewhere around there. What percent of people is this person's score higher than? Not too many? 1%, perhaps, that's right. What is that person's Z-score? Exactly, minus 2.5. So again, all equivalencies up and down the line. In terms of the exam, what I would know going in is I would want to know these numbers and the standard deviation 1, 2, 3 both ways. Are they kind of minimally going in? These would be handy to know. The 68, 95, 99. For Z and T, if you can remember 0 and 1, T, 50 and 10, I would going in, but that's up to you. Now remember, you can't carry this in with you. As soon as you get your test booklet, if you're paper pencil, and if you're on a computer, you're going to be given a scratch sheet to take into the computer room with you. I would draw out the normal curve as soon as you get a chance to. Get it out and draw out the lines, all the numbers to the extent you can remember them, get them out of your head, and then when you come across questions that relate to the normal curve, go back to it, draw in the more information if you have, and then answer your questions. Can't take it in on your knee or your hand and so on. Well, they'll frown on it in any case. In the computer room, I'm not sure how they would handle that, but so in any case. Questions about that? Okay. Let's move on beyond the normal curve and mean, median, mode, central tendency, and variability. And I'm going to talk about the correlation coefficient next. And talk about some of the properties of the correlation coefficient, when we use it, and so on. The one we're concerned about primarily in terms of correlation coefficient is the Pearson product moment correlation coefficient. The correlation coefficient tells you about the relationship between two sets of numbers. That's called a bivariate correlation. A multivariate correlation will look at the relationship between more than two variables, okay? But we're going to just worry about the bivariate one, the two. And remember the test of anxiety and hostility that you'll be taking. We're going to correlate those scores to see if there's a relationship. What do you guess? The relationship, positive, negative? Probably positive relationship. And for some people it might be off the chart. Some people it might be moderate. For some it could be kind of in the middle. So, Pearson product moment correlation coefficient. The correlation can go from a minus 1.00, which means no correlation, to a 1.00, perfect positive correlation. If you ever find one of those or the other, the negative or the positive, give me a call, send me an email. They're pretty rare, those kind of correlations. So I'd love to hear about that. So as two sets of numbers go up, we have a positive correlation. As two sets of numbers go down, we have a positive correlation. One up, one down, that's the negative one, okay? So, let me tell you about a kind of a special case of correlation, and called the curvilinear. And curvilinear correlation is a curved line correlation. And we come across them regularly depending on the kinds of variables that we are measuring or comparing, relating. Let's say age is one, let's say agility is the other in this example. Agility, and let's say agility goes from low to high on this scale. Age, let's start with birth 0 to 100. A curvilinear correlation means that something happens to that relationship between these two variables. At birth, those of you, probably, most of you, some of you probably have had a little guy, girl, and they don't do a whole lot at birth. Babies, they just kind of wait for something to happen. Not a lot of agility at birth, but very quickly they get agile. So the line goes something like this, and then about 100, or not too much agility, rigor mortis sets in, and folks stop moving. So this is a curvilinear correlation. When you do the overall correlation, it might show nothing, no relationship between age and agility. But in fact, if you look at this part of the correlation, as age goes up, agility goes up, a high correlation, right? Positive. And this part, as people get older, age goes up, agility goes down, very negative correlation. So altogether, it can wash out. It looks like no correlation in your data. So it's a curvilinear correlation. So be a little bit careful about the kind of variables. If they're talking about correlations in the test question, are the variables developmental, subject to growth or other kind of issues? If that's the case, you may have not a straight line correlation going on here, okay? Okay, let's talk now about a couple different properties, psychometric properties of tests. And the first one is reliability. These psychometric properties are very, very important and valuable. And for example, the two that I mentioned, reliability and validity, if they're not in your instruments, if your tests and inventories aren't reliable or valid, don't use them. It'd be probably unethical to use them if they did not have those qualities. When we do look for these psychometric properties, there typically is a technical manual that has been designed by the test publisher, in which you will find information about where the test came from, how it was designed, what it correlates to, reliability, validity, and so on. And very, very valuable piece of information, including how to interpret the scores, how counselors can make use of the test and inventory, and so on. So look for the technical manual about information about any test that you might be using. So let's talk about reliability first. And on the bottom of the page, we have reliability is simply the consistency of a test or measure, the degree to which you can expect to get the same results over and over and over again. Types of stability, next item. Stability reliability is test, pre-test reliability, the best kind there is. Okay, so you give a group a test today, and sometime later you give them the same test, and you compare the results from time A to time B. So let's say that I have a test, and I have a couple hundred people in my sample, and I give them the test in the morning, then I give them the same test in the afternoon, and compare the results. Would that be high reliability, do you think, or medium, or low? What's good about morning and afternoon testing? Anything? Pardon? So people are doing it at different times. People are a little bit different. You know, there could be morning people and afternoon people, but what else could be going on from morning to afternoon? Fatigue, tiredness, like, and I've just seen this thing, I've got to take it again, give me a break, some attitude sorts of things. So the chances are the reliability you would generate from morning to afternoon isn't as high as you might like. There might be some issues going on. So what if I test today and I wait a year and then I give them the same test a year from now? Is that okay? It's a long period of time. What could be the issues? It'll be the same people. It'll be, well, I mean, in some senses, it won't be the same people, right? A year later, everybody's different, or could be different. Some could be dramatically different. Developmental things, education things, some have been through counseling, through therapy, through more degrees, more everything. And so you can't expect the people to be the same from now to a year from now. And so the reliability that you might get might be affected by that, right? It'll tend to be lower. Okay. So don't wait a year. The book says wait 2 weeks. So if you give a test today and wait 2 weeks, if the group is still around, give them the test again 2 weeks later, and then look at the reliability. That's a good time frame to wait. That's test 3 test, stability, reliability, very, very good. Okay, so we are talking about stability, reliability, and the second one again, let me repeat that, is equivalence reliability. We have alternate forms of the same test, a Form A and a Form B. So we have 2 different administrations going on, and then we compare the results of those 2 administrations. Now, assuming we can do that with the same group, we can do that, or we can do it with 2 different groups and give equivalence reliability. The third kind of reliability is called internal consistency reliability. And the first one of these is called split half. You take a test of maybe 100 items, you give it to a group, and you don't have a chance to give it to the group again. So how do you get reliability? You split it in half, the test. After the people have taken all of it, split it in half, and you compare the 2 halves, split half. A Form A and a Form B, a split half A, split half B, or however you want to name it. So one of the issues there is about how do you split the test into what pieces and how does it happen? What do you think is an effective way to split a test of 100 items? Odd even is a good way to do it. Random might be another one, or something like that. But in any case, you want to make sure that the 2 halves are fairly equivalent. Otherwise, you're going to be comparing, you know, an unequivalent one with another one that's different too. So split half is a good way. One of the things that happens when you cut a test down, you're splitting it into 2 parts of 50 items. De facto, by default, you are reducing its reliability by cutting the test shorter, making the test shorter. And so to counter some of that automatic lowering of reliability, you can take your split half coefficient result and put it into a Spearman-Brown prophecy formula, something called Spearman-Brown prophecy formula, to see how reliable the test would be had you not cut it in half. Okay, and so you kind of gain back some of that reliability that would automatically happen by splitting it in half. So Spearman-Brown prophecy formula. And you're probably thinking, yeah, I need to remember Spearman-Brown prophecy formula. And you're probably thinking like, so what else do you want me to know? Spearman-Brown is very likely to be a wrong answer. On the exam, there are 200 right answers and 600 wrong answers. Wouldn't it be nice to know the wrong answers too? So you can start narrowing down from 4 to 3 to 2 to 1 maybe. So a lot of what you're going to be studying is going to be wrong answers. I mean, it'll be there, but it won't be the right answer for the question that's being posed. And we all have empty brain cells. We've got tons of empty brain cells just waiting for some action. So stick some of these things into some of those empty brain cells and use them and live with them for a while. And after the exam, you can do a delete or, erase whatever you want to do. Okay. So Spearman-Brown prophecy formula. In any case, if you saw Spearman-Brown as one of the answers, that question should not be dealing with reliability. So it'd be some validation stuff too in terms of, so what is this question really dealing with? Now, I mean, it could be, and that could be the answer, but if clearly Spearman-Brown is a wrong answer, if you know that, then the question is not about reliability. The second kind of internal consistency, reliability, means that you correlate all the items with every other item for a group of people. Say 100 people take this test of 100 items, you correlate all their answers on item number 1 with item number 99 and item 1 with 98 and all of that. You get a whole mass of intercorrelations. You look at those intercorrelations and we see which items are measuring the same thing by the level of their correlation. If all the correlations are high, you know that that test is reliably measuring the same thing. If some correlations are low, let's say that the correlation between item 1 and 49 is 0, you know that those items are not measuring the same thing. So that means your test has some error in it. It's not reliable. So you want all the intercorrelations to be high or tending high, rather than low or tending low. Now there are two sets of formulas to use to get this accomplished. There are Kuta-Richardson formulas if your test has dichotomous items, such as true, false. If your items on your test are multiple choice or essay, the formula to use is called Cronbach alpha coefficient. And again, some extra words for you to think about when you're trying to fall asleep. Now let's talk about two more items that deal with reliability. One is called true and error variance. And let me pose to you, whenever you measure anything with a test or an inventory, and even before I go on, what's the difference between a test and an inventory? Anybody have a quick answer for that? Knowledge is test and inventory is what you have. Okay, that's getting at it. Anybody else? A test has right and wrong answers. An inventory is states of being. It's kind of who you are, your personality, your attitude, your aptitudes, and so on. Where tests are more knowledge-based, true and false kind of answers. Okay, I use them interchangeably, but in fact, conceptually they're different. Whenever we measure a psychological trait or characteristic, we're hoping to measure the true characteristic or variable, okay? But there is always some error that we're measuring. There is never a test that doesn't have some error that creeps in. And that causes the unreliability. So the relationship between error and reliability is you want to minimize the error to maximize reliability. So the more true variance you're measuring versus error, the more reliable the test is. Some tests have so much error that you get a different score every time you take it, way different. And if that's the case, why would you want to use it? That'd be the unethical part about that. So you want to minimize E, the error, you want to maximize the T. Now let's say that you have two forms of the same test. You have true variance in 1, true variance in 2. First one has some error, the second one has some error. You can correlate these two forms of the test. It'd be like a form A and a form B. And let's say that you correlated and you got a 0.60 correlation. You don't know how much true variance they're measuring in common until you square that and take it out. So 0.6 times 0.6 is 36%. So 36% of what they measure in common is the true variance. Only 36% if they correlate at 0.60. which is not very good. That means there's a lot of error here. We have 64% of this thing is error. That's a ton of error. In my book, I think I have 0.8, 0.9, right? I think there's a 0.9, and you square that, you get 81% is my combined factor variable, and 19% is my error. That's a whole lot more palatable. So you need to look for a correlation that's closer to the 90 than the 60 in terms of being comfortable with the amount of variance that those two test forms are measuring. The two items underneath that example box in item 11 are coefficient of determination, coefficient of non-determination. This is the coefficient of determination, the 81%. That's been determined. What's not been determined is that 19%. That's the error part, coefficient of non-determination. And both of those items have been on the exam some years ago. I've not heard about that recently. One more item in terms of reliability, and this is the standard error of measurement. Standard error of measurement, some of you remember another way of referring to this is that confidence bands, confidence limits, standard error of measurement. And the example I use is something like this. Let's say that a person took a test and scored a 92. The SCM on the test is equal to 5. I can make a prediction. Knowing this, I can make a prediction about how the person will do the next time, or 10 or 20 that he or she takes the test. I can predict the person will score between 87 and 97 about 2/3 of the time. Okay, 87 and 97. Now, 87 and 97 is easy, right? Subtract 5 and add 5. How about the 2/3? What does that come to? Pardon? So you're looking at 2/3 as part of that. Okay. Anybody else have another? Okay, it goes back to the normal curve, folks. Remember, the mean is 92. That's your first administration. The next one is 34%, 34%. So I go 87 to 97. 34 and 34% is approximately 68. That's my 2/3. So go back to the normal curve. The SCM works like a standard deviation. Go back to the normal curve and figure out, okay, so how much of that space do I cover by one standard error of measurement each side? 87 to 97 covers 68% of that space. That's about 2/3. I can be even more sure. I can say the person will score between 82 and 102. I can be 95% sure, can't I? And what have I done? I've gone out another part of the normal curve and included 13.5 and the same thing there. 95% sure. I can be even more sure. I can be 99% sure. 77 to 107. 99% of the time the person will, no matter if he or she takes the test over and over again, if this is what I start with, that's the SCM, the person will score here 99% of the time. And somebody will look at this and say, well, what the hell good is that? It's a kind of a broad range here, but it also depends on the size of this. See, this changes on every test. It can change for every test for every population or every group tested. Sometimes the SCM is 2, sometimes it's 5, sometimes it's 7, sometimes it's 12. Can you imagine an SCM of 12 and how big that range would be? I mean, we would be going here from, what, 80 to 104, 68%, all of a sudden. So you really want to lower this puppy down. The higher the standard error of measurement error, the more error you have, the less reliable the test is. So you want to minimize the SCM, make it as small as possible, and then you're also then much more predictable in terms of the next administration. The National Counselor exam has an SCM also, standard error measurement. In fact, a fellow in one of my New Jersey workshops many years ago knew about the standard error concept, and he took the exam, failed it by 1 point. They hand scored if you do that, and he still failed it by 1 point. So he started arguing with NBCC that he should pass because he was within the standard error measurement, right? I mean, give him a break a little bit. Well, he hadn't heard back from NBCC. He came to my workshop in New Jersey and told me about it. And then I said, well, you let me know if they let you pass being within that standard error measurement. I need to know that. He never got back to me, so I knew they wouldn't do that. So everything has an SCM, a test. NBCC's the National Board for Counselors on their NCE exam. I think the SCM is not real small if you include all 8 content areas. But then if you go by content area, I think the SCM is pretty small. That's old data. I've not seen anything reported lately about that. So everything has an SCM. So all of this relates to reliability, and one of the major psychometric properties of tests. Let's go on to the next one called validity. Validity is the belief that you have that the test measures what it claims to measure. And to the extent that it does, that's great. A lot of tests don't measure what they claim to measure or what you believe they measure. But in any case, you want high validity if at all possible. And there are different types of validity. Let me review those, starting with 14. Face validity is the instrument looks valid. And you know, that's nice. But it's even nicer for consumers. Let's say you go to work, or you're applying for a job for a company, a business or industry, and they said you're going to have to take some tests to compete for a job here. And they said it's going to be about general clerical stuff, office stuff and so on. And then they give you a test that's very different, that doesn't look at all like clerical or administrative and so on. And so you're taking that test and you're kind of wondering, what's going on here? Why am I taking this instead of a clerical test that I thought I was taking? Face validity is important for the consumer. It's not so important maybe for the test giver, but if you want people to kind of understand and relate to what you're doing to them with your instruments, face validity is good. Content validity means that the instrument contains content material that everybody claims, or there's some data to claim that that's what it measures. My example is 3 4th grade math teachers in an elementary school get together near the end of the semester and design a final math test, arithmetic test for these kids based on all of their teaching for the semester and their text and whatever else they use. And then they would have a content valid final exam of math for those 4th grade math kids. No matter what classroom they were in, it would cover all of them. Predictive and concurrent validities are often talked about fairly in common. They're both criterion related. Each one of them has a criterion. Predictive means that predictions made by the test are confirmed by some later behavior. I have an example of the scores on a graduate record exam are predict later GPA. Well, some universities probably do that. They look at students' incoming GPAs or incoming GREs and then check their GPAs later and see if there's a correlation. Most universities don't bother doing that because at the graduate level, at least, most students get the best grades. Their GPAs are about 4. And it's very hard to correlate, very, very small range of GPAs to a whole range of GRE scores. It's nice to have a range on both sides, but to find a graduate student with a GPA of less than 3.5 or 3.67 is pretty rare. So usually that correlation doesn't happen. Most folks don't care. Graduate programs don't care. Once you're in and you're in a good program and you're doing well, that's cool. But another predictive example would be this: an employer wants to hire 50 workers, tests 100, admits 50 of those to the job, and then 6 months later the supervisor rates their performance. And that becomes the criterion against which their test score can be measured. And then in the future, they can look for a certain kind of a score depending on what this study found to begin with. There's a criterion there in the predictive sense. Concurrent validity means that maybe you design a new test of something and there are tests already available that measure that. You compare them. You see if your test is consistent with a criterion already in existence at the present time. Concurrent, okay, right now available, not worrying about predictive. Construct validity is a little bit more complex. A construct is a psychological characteristic, curiosity, creativity, anxiety, whatever it might be. And what you do with a test looking to see if it's construct valid, you look for relationships between that construct of that test with other constructs measured by other tests. Let me give you a real world example. For my master's degree, I went to Iowa State University in counseling psych, and I worked as a graduate assistant for 2 years in our counseling center. One of the older professors there had always wanted to design a test of curiosity. And he was very busy, and not too many years from retirement, and so he told me to do it. We do that to graduate assistants. And I had no idea what I was getting into, but it was kind of fun. I'm kind of a curious guy. And he helped me, and we designed 125 items that measured epistemic curiosity. I'm curious about that, I'm interested in that, and so on, intellectual curiosity. And designed this test of curiosity. It had 125 items, it looked nice, it had curiosity inventory on the front. And now, of course, the question was, did it measure anything, like curiosity? We had no idea. It's a construct. I had to do a master's thesis, and my master's thesis title ended up being a construct validation of a new measure of curiosity. In reading the literature, I found that curiosity was related positively to creativity, positively to intelligence, negatively to anxiety. And I thought, well, I'm going to measure a whole bunch of that stuff in a whole bunch of Iowa State sophomores and see if I can get those correlations. And if I can, maybe that's some evidence that I'm measuring curiosity, which would be cool. So I did. 2 measures of creativity, the IPAT scale of anxiety, the curiosity inventory. I didn't measure their intelligence, but I got their GPAs as kind of a proxy for IQ. Had it correlated with the help of a lot of really nice patient people, and it was kind of a nice experience. I had some correlations in the predicted direction, but there was no way, based on that one simple little study, that I could definitively say we're measuring the construct of curiosity with this. Construct validity studies can take 5 years, can take 10 years before you finally figure out which constructs out there, which instruments out there. Finally, I was looking for convergent validation on the bottom of the page, where there was high correlation between curiosity and creativity, and high with GPAs. I was looking for discriminant validation, especially with my anxiety scores. I wanted no correlation with anxiety or a negative one with my curiosity. So those are the 2 concepts that were at play there. Okay, let's go on. Reliability, test may be reliable but not valid. The next item. You turn your bathroom scale down 10 pounds, okay? Boy, you sure weigh a lot less. And then you keep it there and you weigh yourself and you weigh the same thing over and over and over and over again. It's reliable as all get out. But is it valid? No, you messed with that. Tests may be power-based or speed-based. Power-based is like, oh, the NCE and CPCE, even though they have time limits, time is not much of an issue with those. They're power-based. Speed-based are those that are timed strictly. A lot of aptitude tests, intelligence tests are, timed for 6 minutes, 8 minutes, 12 minutes, and so on. Very much a speed-based phenomenon. Assessment may be norm reference, comparing individuals to others already tested. And again, the norms may be national, regional, state. Your agency can develop norms for its own clients, and you can compare new clients to the other clients already in that process. Criterion reference means that there is a criterion, a cutoff score determined, and that's what happens with you folks on the National Counselor exam. Your cutoff score is already determined for any exam given in October. NBCC has the criterion figured out. On the CPCE, typically the NBCC folks let the university decide what the criterion will be for passing the CPCE in their institution. At my institution, we set 65% as the passing CPCE score. Pretty similar to the NCE, but the NCE is usually a little bit lower than that. Okay. Criterion referenced. Ipsatively interpreted means that, back to the real world of mine, after I got my master's, I went back to the state of Wisconsin, eventually got a job there as a vocational counselor, but an employment career counselor with a job service office at Racine, south of Milwaukee. And a lot of the people that I saw were older men, then older, and they were street people. I mean, they had no jobs, they often had no addresses, they lived pretty much on the street. One of the tests we used in the job service was the GATB, General Aptitude Test Battery. It measures 9 aptitudes, and you would give it to anybody and be able to look at their results with a national norm group. Well, I would look at the men's own scores, ipsatively, looking at theirs high, mediums, and lows to see which ones they had that might be useful for them to try to develop and work on and get jobs in and so on. Instead of doing a national comparison, most of these men would have looked really kind of sad on a national comparison, but they all had highs, mediums, and lows of the 9 aptitudes on the GATB. Ipsative. Next page, maximal performance may generate a person's best performance, or you might get a typical performance on a personality or interest test, maximal and typical. I think that concept's been on the exam, somebody said. Number 18, purposes, rationale. 19, circumstances. Take a look at those. I'm not going to spend time on those lists. Regression toward the mean. If you take a test and you score within the top 15 or bottom 15% of possible scores, it's very likely that your score will regress towards the middle, towards the mean, the next time you take the test, because those circumstances change that got you to the top 15 or bottom 15%. Body states, environment, whatever kind of physical circumstances there were will be different. Standardized versus non-standardized. We've been talking primarily about standardized tests inventory so far. Non-standardized ones are very common and very important. These are your rating scales, your checklists. Whatever instrument is useful for you in gathering appraisal data, don't be shy in using, assuming you're not misusing some document and fooling yourself. But there's so many rating scales and other ways of gathering data from clients, other people, that can be very valuable. So you don't need a formal test or a formal inventory for that. All kinds of things can work. I have a list of tests and inventories in the next item here. And it's kind of a long section. I don't want you to do anything but maybe look through this list once or twice. You might be better off kind of focusing on the key categories. So like intelligence, what's intelligence mean, and what might be some measurements. Achievement, the next page I've got primarily academic is what I'm referring to there. Aptitudes, what is an aptitude and so on. Personality, same sort of thing, and then interests. So don't go for reading these lists over and over again so you commit them to memory. Most of these tests will show up, most of the tests will not show up. If any of these tests do show up on the exam, it'll be typically in the question. And as part of the vignette, the scenario, and the experience that they're giving you of a counselor with a client or something like that. Rather than the MMPI measures A, B, C, D, they would not waste a question on a test like that. There is no reason to do that. So don't expect that kind of detail on the exam about specific tests. But if they talk about the Myers-Briggs in the test question, or the the MMPI or something, you'll have some idea how that's going to happen. Semantic differential is the range of possible answers there. I've got the example there. Intrusive and unobtrusive measurement. Intrusive means that the person knows that you are testing him or her. And when they know that, are they changing their responses because of that? Unobtrusive measurement means that they don't know, you're gathering data about them, and it may be that you are recording them after you've gotten permission and signed agreements. They kind of forget that they're being recorded, and so on, and just kind of let it all hang out. Intrusive and unobtrusive. Observation as appraisal technique, we do that all the time. We're constantly appraising our clients, office workers, anybody who walks in the building, and so on. A great way to gather data. Case studies, historical studies, rating scales, interviews, the counseling session, the open-ended questions, all of that is good stuff for gathering data. Sociometry is a way of looking at relationships between individuals who are in established groups, whether it's a work team at a company or a classroom of kids who've been together for a few months and so on. And you usually end up with what is called a sociogram, a visual picture map of their relationships. Social desirability is the issue that some tests allow counselees, anybody who takes the test, to skew their answers the way they want to be perceived. Social desirability. If you're getting a job past your master's for a state agency in counseling, and you take a test, and at some point you come to a question, and you look at the question and you wonder, gosh, I wonder how they want me to respond to this one. Well, guess what that is? That's called social desirability creeping in. And some of you may end up taking exams, tests, inventories for state jobs especially, human services, maybe the prison system, whatever. Using and interpreting test scores, item 29 there. Take a look at that. I'm not going to spend time to review that. Grade and equivalence scores, item 30, that's been on the exam, I've been told. So don't overlook that one completely. Percentile ranks, I think you know what that is. Computer-based assessment. So much testing is done on computers now that we're pretty comfortable with that mode. But let's say that there's a 55-year-old woman who comes into the Colorado West Mental Health Center in Vail. One of you is kind of close to that. And she doesn't even have a computer at home. And pretty much, you said, well, she's got to take, this test, that test, MMPI, whatever. Here's a computer, and so on. And you think that instrument, her taking it there on the computer in her situation, is the same as a paper and pencil instrument? I got a hunch there's some slippage there. And for some people, tests on computers still are pretty scary, and maybe slightly on the invalid side, depending on all the responses and reactions. So I think more and more folks are used to computers, and the data seems to be fairly supportive of putting paper and pencil tests on the computer and that being the same experience. But I'm not sure that that's always the case. So we need to watch out, I think, for folks that might be a little bit skittish about the computer process. Ethical issues in testing. Tests are still biased. Not all the tests that we use were designed for everybody. Sometimes the test questions aren't appropriate for all cultures, for example. Some tests don't have they don't have groups that have been tested before that are well balanced, diversified, and so we have different kinds of groupings that may be inappropriate. So I think tests may still be biased in some cases. Confidentiality is still an issue. How do we treat the data from tests? Who else in the office has access to it? How far and wide do you spread it by computer? Also we'll get into HIPAA here. Computerized testing, we've talked about a little bit. So I think there's still some cautions there under the ethics side. On the assessment resources side, I think the Burroughs Mental Measurements Yearbook would be worth putting into one of those empty brain cells. This is an incredible document, updated regularly even though Oscar is gone. And it's all online, so if you wanted reviews, critical reviews of tests that you were considering using, reviews done by experts in various fields, you can access the Burroughs Mental Measurements system and download a review for, it used to be $15, it's probably more than that now. But I would know about Burroughs Mental Measurement. The other ones I'm not sure I'd be that concerned about. And that's appraisal.